this question, the question that I've given for the assignment, to draw the development of a pentagonal pyramid, and a string is wound around the pyramid through the shortest path, and you have to show the shortest path in the front view and top view. That question, many of the students have committed the same kind of mistake, so I decided to work out this question and send you the video clip. So to begin with, the position of the pentagonal pyramid is not specified actually. So in most of the cases, students went with this kind of a position. There is nothing wrong in it actually. There is nothing wrong, absolutely nothing wrong in it. But in this case, you just complete the front view. This is what you get. Okay. So in this case, none of these slant edges gives you the true length in the front view. Now, how do you find out that? First of all, you need to find out, is there any edge which is exactly parallel to the xy? There is no edge exactly parallel to xy. For in that case, you have to with OS center and this is radius, you rotate it, make it parallel, then you project it, and then you connect using this line. You can do it the same thing here also. Rotate it, keep it upside, find the true length. This is the way you find out the true length. And with this true length, you draw the line, cut a curve, and take this distance using a compass. You take this distance, you cut arcs 1, 2, 3, 4, 5, and then you join, connect these edges, and that is how you get the development. Alright. The point I want to make is that if you choose a position just like this for the pentagonal pyramid, in the front view you will get this edge parallel. If you choose this position, one of these edges, this edge will be parallel to the VP, and in the front view, what you see here is the true length. So you don't need to rotate and perform all those things to find out the true length. Okay, and this is also correct, this position, because in the question it is not mentioned whether the base edge is perpendicular to VP or parallel to VP, right? That's the first thing. The second thing, how do you find out the shortest path? You choose the starting point and the ending point, you connect using a line. So I have finished up to this point, the front view, top view, and chosen the position of the pyramid that you all have done. I think most of you in the sense, all of you have chosen this kind of position. I don't know why. Maybe coincidence, or maybe just you guys copied from each other. I don't know, but since you have chosen this position, I've decided to complete with this one. So your starting point, ending point, you connect it, and you can see this 1, 2, 3, 4 cutting this one. So how do you transfer these points here? So the moment you begin to transfer points from a development to the front view, this is what you have to keep in mind. All these lines are true length, and whenever you transfer this dimension from a true length, you have to transfer it to the true length line here in the front view. If you don't have a true length line, you make it one, just like you're seen. Okay, so the point is, if you want to find out the 1.1 here, you have to take this distance O1. This is an OB, right? This is an OB. You transfer to the true length, and then what do you do? Then you draw a line so that you get an intercept here. So that's your 1 dash. Right? Now how do you find out 2, 3, and 4? The same way. Take 2, offset in the true length line. Take 3, offset in the true length line. That's very much, there is not much difference in 2 and 3. Take 4 also, offset in the true length line. And then you draw lines. So your 2 is, we'll start with 2. 2 is on C. So C is right here, the last one. So that's your 2, and 3 is actually on D. 3 is on OD. OD is on the behind side. So 2 dash and 3 dash are almost very close. Now how about 4 dash? 4 dash is different. 4 is on OE. This is your OE hidden side. So that's your line. Okay. This was my marking, and this is 4 dash. Mark it here. Right. Now up to this point everything is fine. If you want to connect from 1 to 2, 3, 4, 5 again to A, that's the way you connect. So A dash to 1, I'm using a red line, and 1 to 2. Okay, so A dash to 1 dash, 1 dash to 2 dash. This A to this, this is O dash A dash, and this is O dash C dash. So OA and OC, you can see this is your visible side. Or else you can say that if you look from the front, you'll see from OA to OC, that's your visible side. So behind that, from CDEA, this side, it's a hidden side. So whatever points that you mark there, you have to mark it in a dash line fashion. So 2 dash to 3 dash, dash line, 3 dash to 4 dash, again a dash line, and 4 dash to A dash, again a dash line. That's it. Okay, now how do you find out 1, 2, 3 here? So 1, when you draw a projector, don't get an intercept. So what you do is you shift your 1 dash to side. You already have that point, so I'm going to draw a line straight from that point until you get to
C. Okay, so this is my
transferred point, and then I have to rotate that thing. Many of you have done this, but some of you have shown this mistake. Okay, so that's your 1. Now how about 2? The rest of the points you just need to draw straight lines until you get to that corresponding edge. 2 dash is on O dash C dash, so this is your OC. From 2 dash you drop a perpendicular until you get to OC, that's your 2. Similarly 3 is an OD.
There 3 comes here. 4 dash, from 4 dash to perpendicular, that's your 4.
And again you come to A. So now mind you, what I've done here is I have connected all these points using a straight line. Why is that? Because of this. If you have a pentagonal pyramid, you have flat surfaces. See, flat surface. Even if you want to string or this thing from here to here, you have a flat surface. So the path is always a straight line, not a curve. Whereas in a cone, you have a curved surface. So the passage or the path will always traverse along a curve. Whereas here you have all flat surfaces. So that's why you connected using a straight line. Now many of you have missed this point. Many of you assumed that this solid line coincides with the hidden line, so you don't need to draw the hidden line. That is wrong. That is a common mistake. And some of you have drawn connected these points using a curve. That is also wrong. So this is your correct answer. 2 to 3, 3 to 4, and 4 to 8. So basically, to show you the difference. So that's your path. When you look from the top, okay, when you look from the top, you see this as a path going like this. Whereas when you look from the front, you see the solid line, or the visible side, you see this path, and the hidden side, this one. So you have to show the hidden line. If it doesn't coincide with the solid line, you have to show it as a dash line. That's mandatory. So this is the answer, right? I want you to try this.